Hello everybody, this video is going to be about factoring trinomials. Okay, so remember in the last video I talked about how factoring is the opposite of the distributive property. So factoring is undoing the distributive property. That's what I talked about. So I thought it would be best to look at a distributive property problem when we try and figure out how to factor. Okay, so the first thing I'm going to do is I'm just going to double distribute. You might call this FOIL. I think that's a silly name, but I like calling it double distribute. So x times x is x squared. X times 12 is 12x. Negative 5 times x. Negative 5x. Negative 5 times 12 minus 60. All right. Then, if I simplify, I'm going to get x squared plus 7x minus 60. Now, if I were to ask you to factor x squared plus 7x minus 60, you might have a harder time doing that. But let's take a look at where each thing came from. The x squared came from the x times the x, right? So it just is the first two terms. And when this number in front is 1, like it is, right? 1x squared, this is actually as easy as factoring gets. Additionally, we have the 7x, right? We have the 7x. That comes from these two middle terms adding together, right? So to make the 7, I need to think of two numbers that add to 7. And to make the 60, to make the negative 60, it was the negative 5 times the positive 12 that did that. So when I look at this, you might set up an x like this. I've seen a lot of people do this. And you might say negative 60 and positive 7. And I need two numbers that multiply to negative 60 and add to positive 7. Some people will call this the x, the ma, a diamond, whatever you want to call it. Just make sure it works for you. So now I have negative 60 and positive 7, I need to think of two numbers that multiply to negative 60 and add to positive 7. Well, of course, that's positive 12 and negative 5. I like to write the signs in this little x just so I remember. When this leading coefficient is 1, like it is here, right? This is super easy. We're basically done. It's just x plus 12 and x minus 5. Of course, we knew that from where we got this problem from. But there you go. Of course, factoring gets a lot harder. Before it gets a lot harder, let's try examples C and D here, and then we'll go over some other harder examples. Example C, x squared minus 12x plus 36. Okay, that leading coefficient is 1, so this is one of the easy ones. All I have to do is think of something that multiplies to 36, but adds to negative 12. And when you're not sure, go ahead and make a list. So like 36 is 1 and 36. It's 2 and 18. It's 3 and 12. It's 4 and 9. Keep listing out the factors. 5 doesn't go in. 6 and 6. I don't need to keep going because I've repeated a number. So that means I've hit all of the numbers because otherwise I'll just go, my next one would be 9, which is already down. So now, of course, 6 and 6 can make 12. And in order to multiply to positive 36 and add to negative 12, we need them both to be negative. So this is x minus 6 times x minus 6, which you could also write as x minus 6 squared. Both of these are acceptable. On this next example, negative 2x squared plus 2x plus 60, it looks like this is one of the harder ones. The first thing I want you to notice is that this has a leading coefficient that is negative, okay? That's the first thing I want you to notice. And I'm going to right away think, I want to factor out that negative. But not only can I factor out that negative, I can divide -2, 2, and 60 all by -2. So I'm going to do that. I'm going to take out the -2, and then I have x squared minus x minus 30. Now, I can ignore this -2 out front. The reason why I took it out is so this problem would be easier. And now I have -30 and -1. So I need to think of two numbers that multiply to -30 and add to -1. So that would be 1 and 30, 2 and 15, 3 and 10, 5 and 6, 6 and 5. Okay, that's already on my list. 1 and 30 won't make a -1. 2 and 15 won't make -1. 3 and 10 won't, but 5 and 6 will, if the 6 is negative and the 5 is positive. All right, so that means that this is 2 times -2 times x minus 6 times x plus 5. So when your leading coefficient is 1, or you can make it 1, these problems are very simple, but they can get harder. For example, let's do example A. And what I'm going to do is I'm going to show you two different ways to think of it. I'm going to show you how to do it by guess and check. And I'm also going to show you how to do it by grouping. So if I'm doing 2x squared plus 5x minus 12, the first thing I want to do here, when I'm guessing and checking or factoring by puzzling, we'll talk about why I call it the happy unibrow later, okay, is I'm going to take a look at the things that multiply to the leading and last term. So 2 is just 2 and 1. 12 is 1 and 12, 2 and 6, and 3 and 4. Now I'm just going to mix and match these. It's literally a guess and check, okay? I'm going to set up my parentheses. And I know I need a 2x and an x. I have no other way to get to 2x squared. I need to use 2 and 1. But now I need to decide how I'm going to mix and match these factors to make the positive 5. Now, to do this, I just guess and check. I say, okay, if I take the 2 and I multiply it by 12, that's 24, and then 1 isn't going to get me close enough to 5. What if I switch it? What if I say 2 times 1 is 2, and 12, that's not going to work either. Okay, 2 times 2 is 4, which is pretty close to 5, but 6 and 4 won't get me to 5. Or 6 times 2 is 12, and 2, that won't get me to 5. 3 times 2 is 6, and 4, that won't get me there either. But 4 times 2 is 8, and 3, that can get me to 5. So I'm picking this one right here, because the 4 times the 2 will give me 8, and then with 3, that can get me to 5. So I'm going to put 4 here, because I know it needs to multiply with the 2. Which means the 3 has to go here so it can multiply with the x. Now, I'm going to go ahead and pick my signs so that the 5 will be positive, right? 2x times positive 4 would give me 8x, and negative 3 times x would give me negative 3x. So this is why we call it the happy unibrow, because if the top and bottom curve here, you have your unibrow and your smile, if they add up to your middle term, then you did it right. And this is a good factoring. There you go. Let's try the same example by grouping. Okay, let's try the same example by grouping. So, if I have 2x squared plus 5x minus 12. When this number in the front is bigger than 1, when it's a not 1, what I need to do is I need to account for that by multiplying. Normally, we would just take a look at when we built our x, we would put a 12 up top. I'm going to take 2 times 12, first times last, to get negative 24. And then I still need to add to 5. So I need to think of two numbers that multiply to negative 24 and add to positive 5. Well, that would be positive 8 and negative 3. So now what I'm going to do is I'm going to split this 5x up into positive 8 and negative 3. I'm going to say 2x squared. I'm going to keep my minus 12, but I'm going to split up my 5x into plus 8x and minus 3x. What I've done here is I've just uncombined like terms. And if you take a look at what happened when we did double distributed earlier, it's quite similar, right? If I'm going backwards. I started with this, and now I'm making it look like this. So now I just need to go one more step. To do that, this is where it gets its name grouping. I'm going to make two groups. The first half and the second half. And I GCF each half. So, in the first half, they both have 2x in common. So 2x times x plus 4. In the second half, remember I told you, take out the negative if you can if it starts with a negative. So I'm going to take out a negative 3, and that'll leave me with x plus 4. What you should notice is that these match. If you did this right, they always will, right? The reason why is that that this is important is that these are now a common factor of the whole expression. X plus 4 is now a common factor of both 2x times x plus 4 and negative 3 times x plus 4. So what I'm really doing here is I'm GCFing the whole x plus 4 out, which just leaves me with 2x minus 3 as my other factor, which is exactly what we got in our last method. Okay. Let's try this last one. 12x squared minus 11x minus 5. I'm going to do it both ways again. Okay. 12x squared minus 11x minus 5. So if I'm guessing and checking, I'm going to start by listing out the factors of the first and last term. So I have 1 and 12, 2 and 6, 3 and 4. I have more options at the beginning here, but I have only one option at the end. So again, I'm going to build my parentheses, and I know one's going to be 1 and one's going to be 5 because those are my only two options. I need to make 11 this time. So I need to mix and match. I need to say, okay, I could do 12 times 5, and that's 60, and okay, 1, that's going to be 2. That's way too big. 12 times 1 is 12. 1 times 5, that'll make 7 or 17, not negative 11. Okay. 6 times 5 is 30, and 2, that won't get me there. Or 10 and 16, and 6, they won't get me to 11 either. 4 times 5 is 20, and 3, that won't get me there. But 3 times 5, 15, and 4 will get me there. So I need the 3 and the 5 to multiply. So they need to be in opposite parentheses. Now I need to pick my signs. So 3 times 5 will make 15. That's the bigger of the two, so the 5 needs to be negative because the 11 is negative, and then I fill in my other sign. Now I'm going to check with my happy unibrow. That makes negative 15x. That makes positive 4x. That is a happy unibrow. They check out to a negative 11x. Alternatively, I could do the problem by grouping. And it's truly your choice what you do. If I have 12x squared minus 11x minus 5, I need to take my first term and my last term and multiply them and get negative 60. And they need to add to a negative 11. 60, let's just go through quickly. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. 4 and 15 will get me there. Now, you'll recognize this as the two numbers that we used in our happy unibrow, all right? That's not a coincidence. That's why that's the connection between these two methods. So now 12x squared. And remember, we're going to need, what, negative 15 and positive 4? Remember, it doesn't matter the order you write these in. So if I write negative 15x plus 4x minus 5, that's okay. And if I switch the order, that'd be okay too. Now, I take the first set of parentheses and the second set of parentheses, build those. My first half has a GCF of 3x, and that'll leave me with 4x minus 5. My second set of parentheses doesn't have a common factor, but their GCF, therefore, is 1. You can divide both of them by 1. That's perfectly fine. And that'll leave me with 4x minus 5 on the inside. I have a match. That's good. So 4x minus 5 is one of my factors, and my leftovers, 3x plus 1. And there you go. That's factoring trinomials.